we will now discuss yet another important concept in physics, that is the concept of energy. Energy is something that we use in our everyday life. Now, what does energy means in a layman's language? Have you ever heard somebody saying, "Oh, I feel I have no energy today"? And I heard my daughter saying the other day, "Oh, I need some sugar." Apparently sugar gives you energy, I think. What does that mean when you say you have no energy? It means I don't feel like getting up. Well, if you want to get up, that means you are doing work, you are lifting your weight. So when you say you have no energy, what you're saying is that you don't feel like doing any work. That means energy is related to work. Is that right? In fact, energy is required to do work. If you have no energy, you cannot do work. And so, a simple definition of energy is the ability to do work. If you are able to do work, then you have energy. If you are unable to do any work, then you have no energy. Now, what is the unit for measuring energy? Since we defined energy as the ability to do work, isn't it reasonable that we measure energy in the unit of work? Yes, I think so. So, energy is measured in the same unit as work. And what is that unit? It is the joule. Energy is measured in joule. 1,000 joules is a kilojoules. 1,000,000 joules is a megajoule, and so on. Okay, let's consider a book of mass m gram on the floor. Now this is the floor level. We have a book of mass m kilogram. Tell me, what is the weight of this book? The weight of the book is mg Newton. And what is the direction in which that weight is acting? It is acting vertically down. So when the book is on the floor or on the table, the earth is pulling it with a force of mg Newton. Now tell me, what is the force required to lift this book without causing an acceleration? In other words, the force you require to lift that book without causing an acceleration is the force that is needed to balance so that the net force is zero. What is that force? Since there is no acceleration caused by lifting, there should be no net force on the book. If there is a net force on the book, that net force will create an acceleration. Since we don't need an acceleration, all we need to do is to make the net force equal to zero. What do? Therefore, in order to lift this book, you need to apply a force F upward so that F minus mg equal to zero, or the magnitude of that force is equal to that mg. So F minus mg equal to 0 or F equal to mg. In order to lift any object, you need to apply a force equal to its weight upward. Well, that's a very simple concept, is that right? Now here I have a bag sitting on the table. If I want to lift it, what is the force I need to apply on it? It's a very heavy bag. Its weight mg is acting vertically down. In order to lift it without causing an acceleration, well, remember that exists only in theory. In practice, the moment I lift it, I am causing an acceleration. But at the moment, I don't want you to consider that acceleration. In order to balance the force, what I need to apply is a force upward equal to its weight. I am applying a force F upward, which is equal to the weight of this bag. In order to lift any object, I need to apply a force equal to its weight. Now here I have a 500 gram, about 4.9 Newton sitting on my hand. Now what is the force I need to apply to lift it? Is 4.9 Newton. Okay, let's now use this to describe two types of energy. This concept can be used to explain the concept of potential energy. We now know that an object of mass mg, in order to lift that object, you have to apply a force F equal to mg on that object. So force F equal to mg is required to lift the book without causing an acceleration. Now let this force lift the book through a height h. Alright, we are going to apply this force F and lift this book through a height h. Tell me, what is the work done by this force? The work done by this force now is this force multiplied by that displacement, that is h. So the work done is force multiplied by that distance, and the force equal to mg, and therefore the work done on this book to raise it to a height of 2 meters is mgh, to raise it through a height of h meter. The work done is mgh. Well, this is the same as saying that the energy used in doing this work is mgh. If I have this object of mass m lying on the floor, it's lying on the floor, and I'm going to lift it through a height h. I'm going to apply a force, and that force equal to mg, and that force mg is lifted through a height h. That means I have now used a part of my lunch energy to do this work. How much energy did I use? I used mgh, that force multiplied by that height. So the amount of work done to lift this object through a height h is the same as the energy used in doing this work. Now remember, work done and energy used up are the same thing. When I'm doing work, I'm using up energy, right? If I suddenly want to jump onto that table, I have to do a tremendous amount of work. That means a lot of energy is going to be spent on that particular activity. The energy in turn allows the book to do work when you stop supporting it. Now look at this. I have done work on this object. How much work did I do? I did an amount of work mgh. Now if I let it go, it can do work. Well, what kind of work? Well, oops, my foot. Did you hear what happened? It went and did work on my foot. Well, I didn't really let it fall on my foot, but imagine if it did fall on my foot, it would have done work on my foot. So that means when you raise an object through a certain height, you have now placed that object in such a way that it is now able to do work. We say it has the potential to do work. When it has the potential to do work, it has potential energy. Well, So the book placed at a height h has a certain amount of energy stored in it. This energy is called the potential energy. In other words, that book has now the potential to do work. It has potential energy. If you look around, we use a large number of circumstances where energy gets stored so that that stored system has the potential to do work. Can you think of some of the systems where energy gets stored so that it has the potential to do work? Well, you are actually watching one example. I stored energy about half an hour ago. I had a sandwich. Well, I have stored energy. And that means I am able to do work. That stored energy is actually a form of potential energy. There are many other examples. Let's take a look at a couple of those examples. An example that is not very difficult to understand is stretching of a spring. When I do work on the spring, look at that, I'm going to apply a force and move that force. Means I'm doing work. Now, you know, if I take my hand off, it is going to do work on me. Oops. Did you see how it is able to do work? Now, a stretched spring has potential energy. There is energy stored in it. Well, if I want to get this pen onto a student over there who did not bring a pen today, look at that. All I'm going to do is I'm going to do some work in stretching this elastic band, and you can see the pen went all the way to the other end. It hit me also. Well, a stretched elastic band has potential energy. It is capable of doing work. Now, if you look here, I have a spring-loaded gun. Now, I'm going to do work on this. Look how I'm going to do work. I'm going to apply a force and allow that force to move. Well, apply the force and allow that force to move. And this system now has potential energy. It is capable of doing work. Now, look at the work it is going to do now. There you are. You can see it did work. So, systems where energy can be stored, those systems have potential energy. So tell me, what is the potential energy of an object that is placed at a height h? The potential energy of the object placed at a height h is the amount of work you did to place it there. And how much was it? You remember? mgh. If you raise an object through a height h, its potential energy is mgh. That means if you let it go, it can now do that much amount of work. It has the potential to do that much amount of work. So, potential energy is represented by the letter uppercase U, and of course it is measured in joules. Whenever you want to represent potential energy, we will use the uppercase U. What is the potential energy of a book placed at a height h? The potential energy of a book placed at a height h is a measure of the work done in order to place it at that height. And that is U equal to mgh. In fact, the potential energy of any object that is placed at a height h is mgh. Alright, tell me,